All right, so let's go ahead and get started. So, good afternoon to all. Our deepest thanks and appreciation to ASNE for your 137 years of service in advancement and naval engineering and for sponsoring today's webinar. I'm Jim Kenny, VP Navy Affairs, Fairbanks Morse Defense, and a veteran of NAVSEA field activities and engineering for over 39 years. We're honored to be with you today and to discuss pit stop, collaborative innovation, bringing enhanced readiness to the warfighter. With us today are the true drivers of pit stop, Norm Stoddard, Keith Hassel. Norm, over to you for a brief introduction, and then we'll pass over to Keith and we'll get started.
Good afternoon, everybody. Thank you, sir. My name is Norm Stoddard. I'm here at NSWC Philadelphia. I've been here about 20 years now, working the LSD and the LHA, LHD platforms. And prior to that, I was a diesel inspector in the Navy with 24 years of service as Master Chief Engineman, and been working the pit stop program. So, Mr. Keith.
Thank you, Norm. Keith Hassel. I'm the president of the aftermarket and technology divisions at Fairbanks Morse Defense. I've been engaged with maintenance my entire career, which is over 30 years here now. Really excited that y'all had the opportunity to join us today, and looking forward to getting some questions at the end.
Awesome. So if we can make sure that we've got participants on mute, well, we'll go ahead and get started. So thanks, gentlemen, for your introductions. Keith, let's start with you by grounding the discussion. What exactly is pit stop? And then Norm, you can chime in on emphasizing things.
Thanks, Jim. So for me, in its very simplest form, pit stop is managing a predictable outcome, right? Trying to get the right parts, the right processes, the right people in the right place at the right time to manage very complex operations in a very short window of opportunity. So when you think about how things were done in the past and how things can be done, a lot of times you can go look at something, figure out what you need, and then go get what you need, and then the tools you need, and et cetera. But we're pre-staging all the parts that we need for the availability in Connex boxes, shipping them to the site, the tools we need in Connex boxes, shipping them to the site with all the pre-approved OQE, all the pre-approved processes, and all the right trained, certified technicians to perform the work in a very short window of time.
Well, we can add.
Well, that was excellent. Really, it helps us get the warfighter back out and get underway. We have, in this compressed opportunity, these time frames of the 36-month OFRP cycle, and availability is running as they do. We had to find a way to spread the maintenance out across the cycle. So the pit stop was an opportunity to get together with industry and say, how do we fit X amount of maintenance into X amount of time? And what requirements do we shuffle? How do we shuffle and put it together so that we can broad brush instead of doing it in a 9-month time frame? We could spread it out across the 3-year cycle and all the CMAVs. Over.
Awesome. Thanks, gentlemen. And so as we look now on what is exactly is pit stop, and that focus on readiness, the focus on prescribed repairs to ship service gen sets and main propulsion gen sets. Let's talk about why pit stop and why not. Norm, if you want to lead that off.
Sure. What right around the turn 2020, 2021, we had gone through a baseline of our maintenance requirements in our class maintenance plan in the LSD platform. We had realigned provisioning to maintenance standards, to requirements, and we had tied those all to the CNO avails. Lo and behold, we get hit with the proposed decom, and the CNO availability is getting canceled. And when that happened, our SSDGs, we had about a 66% reduction in mandatory technical requirements. And for the main engines, we had about a 70% reduction. And what that really turned into was we had 28 SSDGs in our fleet that were at or over their operating hours for that time frame, and we were seeing degradation in the diesels through our diesel readiness system program, which allows us to monitor, lube oil and performance testing. So without CNO availabilities to schedule the maintenance and to try to prevent downtime, we really had to find another way to do the maintenance. So we had, because we had just finished the realignment of the class maintenance plan, we took those items that supported the prime mover. So those items that were for the center section, power assemblies, the fuel systems, fuel racks, fuel injection, fuel pumps, and what was the minimum requirements that we needed to support the warfighter and to bring that engine back into a readiness condition. So once we down selected those requirements of the class maintenance plan and splitting out, the 36, 72, and 144 month requirements to align to that we had aligned to the previous availabilities, it gave us a down selected set of requirements, and we approached Fairbanks and we said, we have this 6-week, potentially 8 or 12-week time frame. How can we make this work? And then by assembling basically a high velocity working group with RMCs, with DLA, NAVC, NSWC, Fairbanks Morris, we were then able to look at and break out the requirements and determine OQE level, determine process, determine procedure, and start building the architecture that thus became Pit Stop. So we assembled technical work documents for both the shop work and the shipboard work. We separated the material and the parts kits into those two segments. So any component that could be reconditioned within the shop environment would then be placed into the Connex box with the OQE. And that OQE can be provided to the respective RMC at the award. And then that Connex box becomes certified for the repair. And then the second technical work document would capture all the onboard products and make all of that, come together at the end with a certification package from the RMC Chang to be able to certify that work and that repair having been done in the two separate events. By doing so, we were able to get our SSDG overhauls, which normally took us 3 to 6 months. In the CNO process, we were able to get those down to 24 days. The main engines, we did 3 pilots on 3 PC 2.5s, and we were able to get those down to 34 and 38 days respectively with a TAO, temporary access opening, and without a temporary access opening. So Mr. Keith.
Thanks, Norm. Yeah, I would say why Norm covered pretty well, but when I think back to, when Norm first approached us about, trying to do something different in a very short period of time, it was really exciting and it was intriguing for us. Coming off a lot of work that we've done that's been extremely successful and some that not so much, right? Being able to put that rigor to a process to get to that predictable outcome and give a product back to the fleet that we could all be proud of and we knew that it would work was a very exciting opportunity for us. So we were all in. I would say, having the openness and communication and the teamwork environment that we had, we were able to, through some spirited debate sometimes, resolve some of the issues that cropped up in some of these, that affected, kind of both sides. And I think, working that way, getting to that very first pilot that we did allowed us to enter that pilot with an extreme degree of confidence because we'd all worked hard together on a solution and we all believed in that solution and we knew we were going to work hard to make sure that that solution worked out right in practice. So why I think is really getting back to that. How do we get something to the fleet faster and better than we ever have in the past? And that was the challenge. And working together, I think we answered that challenge very well.
Awesome. Thank you, gentlemen. So we've got a pretty good understanding of what pit stop is, a basis for the pit stop, and we've started to address some of the results. But let's focus on what does this collaboration produce today. If we can summarize the vessels and outcomes, and then that would be real helpful, I think, to get us all on the same page. So Keith, if you want to start out on that.
I'll let Norm take this one. He's probably got good notes in front of him, but just again, starting from pilots and SSDGs to, gosh, we've done 6 now, and the main propulsion engines as well. Norm, you probably got a better running list than I've got, but talk to the outcome a little bit.
So we started with the first vessel and the first engine, and that we were really surprised to get through there. We didn't have an access cut. The rigging paths and the rigging challenges presented the first barrier to us, and once we got through and started figuring those processes out, the second pilot we did was trying to accomplish 2 engines at the same time, and we were able to, with the lessons learned from the first one, we showed up with Connex boxes, same vessel, different CMAV timeframe, and we were able to get both SSDGs done within the 28-day timeframe with 2 crews working 2 shifts. We've since done 5 SSDGs, which are the OP 8 and 8 12 cylinders. Then we decided to take that model to the PC 2.5. So Gunston was our first vessel. And then we shifted over and we were able to get through that. And we did not have an access cut. So we, again, had the barrier of rigging and laydown areas that we had to work through. But the engine assembly and the engine process and the teamwork through the process was amazing because we had built a group. The foreman, we developed what's called a diesel engine council, and we had the program manager, the port engineer, we had the prime contractor, the subcontractor, the RMC QA, the product support engineer, and the diesel inspector all meeting every morning throughout production. We were able to reduce CFR processing time down to 3 days. With the development of the requirements, we had also established a series of contingency items from reviewing the availabilities and understanding where our growth work was coming from in previous availabilities. We took items like on the SSDG, we had the vertical drives, the salt water pumps, the lube oil pumps that were sitting in the Connex box ready to go, so that if we ran into an issue during the event, we had a verbal confirmation at the diesel council, the presentation of the information and the OQE with the CFR. We got the approval from the entire gang at that time frame, and then we were able to move out and provide limited trouble to the schedule. We actually had minimal growth outside of anything that we had planned. Some of the lessons learned that we did was we had gone into some of the fuel racks, and the expectation was we would take bearings and some of the gingerbread. But as we got into it, we found that we had to expand the requirement and add some more of the mandatory technical requirements from the availability into the process So we were able to grow it and right size it and come out on the other side with a SAT performance test that was completed within the prescribed time frame for each one of the prime movers. Our actual first PC 2.5 underway, we had achieved engine balance within the first 55 hours of the engine break-in, which was something that normally does not happen when we're coming out of our CNO events. So working with that detailed crew and having the certified mechanics and the teamwork and everybody working together on the deck plate, it really proved beneficial and efficient in getting us through. So we also boilerplated the process in our eye level activity, and our eye level was also able to perform following a similar model in a little longer time frame. We had a 68-day event, and the RMC was able to execute the same process. Just took them a little bit longer. We haven't had the amount of success that we've seen with the depot level model in any other repair that we've tried or any other process that we've tried. So it's really breaking news here to have this pit stop go. So 5 SSDGs and 3 main engines. We got a 4th main engine coming up here in July, and we're actually looking to convert this into the class maintenance plan as a mandatory technical requirement for future maintenance events. Keith,
So
anything?
Keith, if I can just focus a little bit on that discussion on talk about the team and the people.
Yeah, so the team, again, when and there's a lot of other people, you know, that have been involved and have helped to orchestrate this coming to life, right? Think about, you know, the folks at Fleet Forces who, you know, believed in a different process, you know, the TICOMs for, you know, helping to fund it, right? But really, when you get into the RMCs, the diesel engine inspectors and the program managers and everybody working together on the deck plate to accomplish the mission and really do this stuff in real time. Everybody comes to that diesel council empowered to make decisions, not just to take information away and go ask someone else. So that's been super helpful. And there's another piece of that is kind of the unseen piece, and that's all the work that gets done in the shop in between the events, right? All of these parts come off of the ships and they all have to be reconditioned. There's processes for that too. There's OQE for that. There's approvals for that as well. So having that, you know, our shop team also orchestrating with the Navy team has also been very helpful because it's made that happen. We've got a pretty tight timeline of how we turn those things around, and without process and without teamwork, we wouldn't be able to do that either. So there's a lot of fingers in this pot that are making it happen. There's a lot of folks that are, you know, doing the hands-on work, but there's a lot of other stuff going on behind the scenes that has kept this moving and has kept this, you know, getting us from a pilot to a program and then from, you know, ship to ship to ship. So that's been, you know, absolutely tremendous.
So hopefully that will translate that to a movie, right? So let's don't lose sight of, and if you can just hit real quickly the men and women on the deck rates, and you know, talk about team makeup, experience levels, and how those folks are ready and distributed across the fleet to help.
That's a me question.
Yeah.
About our team. So we've got a very rigorous certification process for our diesel technicians. And so what we do is we take a team led by a foreman, right? Who's, you know, your real pro from Dover, been around, done a lot, is certified in multiple product lines, and has also some ability to program manage, project manage on the deck plate. And then we surround them with a team of certified techs who can be, you know, instructed on what needs to be done today. What does success look like? How do we know at the end of each day that we're winning? So that we know tomorrow or the next shift that we can continue on. And that level of communication and sort of choreography on the deck plate is super important to meet those 24 or 28 day schedules. You know, you think about all the things that have to come come off of the vessel, all the things that have to come on in the right order, right? Get assembled in the right order, get the QA done in the right order in order to get to a complete assembly. It's a significant amount of work. And, if everybody didn't show up when they said they were going to, and if everybody didn't participate, there's no way to meet that schedule. So that level of deck plate, awareness of the amount of things that have to go on a shift and the amount of things that have to go on in a day are really what makes that possible.
Awesome. Yeah, so lots of hard work by dedicated teams and certainly a deep choreography on movement of material, which is probably one of those biggest areas of how you keep the train on time. It's how you make sure that the right stuff is in the right place at the right time. Both
Yes,
for
sir.
execution as well as rehab.
And just to expound on the contingency spares for a while, again, there's things that we know need to be done to get us a final product, right? But as you go down there, you can find things that you're not expecting to do, a water pump or a heat exchanger, something like that. So we have those things pre-staged it's kind of like NASCAR. You watch them come in, a lot of tires and a lot of gas, right? But every once in a while you need a transmission. They got one of those in the trailer, right? So it's kind of that same thought process to ensure that if we do run into something that we don't expect, that we have the ability to pivot. We have the component, we already have the OQE, and then we have the buy-in at the Diesel Council to go ahead and pivot and get that component changed as well, which allows us to continue to move and not wait for something that we weren't expecting to happen to come in.
Awesome. If we can just riff on that for just a second between Nolan and Keith, when you look at how have we kind of had the dialogue to understand what's reasonable contingencies and the best approach to have those pre-engineered, pre-ready, and just kind of just a brief explanation of that approach and how that was accomplished to date and continues to evolve.
So one of the things we did when we down selected was we looked at the requirements from how we were executing availabilities, and there was maintenance that was usually done in every single availability. So we kind of broke it up into the core block, like I said, power assemblies and the fuel injection equipment that's needed for operation. All of the other bolt-on equipment, the auxiliaries for each one of the fluid systems and the air systems, we looked at the failure metrics that we get from our Corona. We looked at what were the 2 kilos that the sailors were dealing with, what were the high failure parts. We also looked at what was the top failure modes for mean time between corrected maintenance, because we look at A sub O a lot and we look at mean time between failure, but how many times does a sailor have to put a wrench to the prime mover, right? So we took all of those items, and then from the diesel inspection reports and also the feedback from the DEIs in each of the RMCs and the fleet concentration areas, we surveyed them during the high velocity working group and pinned down those items. And then usually if it was boltable and it was could be removed and rebuilt and be set on a shelf, it was something we were targeting for contingency material. And the other side of that coin is, the stuff that you can't do or that doesn't fit. We actually had one of our engines, which was engine number 6 on our pit stop. When we got into it, we had a crankshaft issue and we had a block issue. At that point, it's no longer a pit stop, right? It turns from a regular overhaul or a life cycle maintenance requirement, if you will, into a corrective maintenance environment. So at that point, the crankshaft needed to be replaced, the block needed to be repaired. So pit stop stopped at that point, and then we turned and we shift into corrective action mode. So when we get to piece parts, the Conex box, we had one box for all of the material that was part of the main. We had one Conex box that was set up for contingency material. And again, each contingency component that was reconditioned had all of the OQE and the technical work document with it packaged, ready to go. so that if the CFR came in to say that I need that lube oil pump, at that point in time, the OQE would be turned over to the RMC. The RMC diesel inspector would approve it. Program manager would approve it, and then the part would be utilized and the process paperwork would go through and support it. What else? Just draw a blank. Help me out, Keith.
That's awesome. That's awesome.
No, it is awesome. And, again, Norm alluded to, right, the amount of data that was available for the team to review to really come to those determinations was really powerful, to go back and look at DEI reports, look at Corona data, to look at all the data that, Norm and his team up in Philadelphia have that they use, to develop their processes and the diesel maintenance strategy to begin with was very helpful in us coming up with that list of parts. I will say that, I think we did a really good job of hitting that first pass. Again, lessons learned, you always find something that can be improved. And we've really taken a continuous improvement mindset to this whole process. So as we learn things as we go along, we can again pivot, we can adapt, we can make sure that, as we go forward every time, we're more prepared, we have the right equipment again, and for the contingencies that could pop up.
Awesome. If I can, just to kind of foot stomp for our participants here, and particularly those that are with NAPC and the warfare centers, don't underestimate the sheer value and power of using the Corona Naval Warfare Center Corona reliability data, that one singular repository for the Navy in regards to reliability data. And how do you share that with your maintenance activities, be it public and private, and make those things turn those into actionable results and frankly catalysts to stimulate those of us that want to come into the business and make a difference. And so, the unpaid political announcement there is that is extremely powerful information. And how do you work together with your ISEA partners, your NAPC partners, your RMC partners, et cetera, to best utilize and make that accessible and use that for the benefit of the fleet. So as we talked about, so we've got parts. We start with initial cache of parts, both refurbished that you harvested from some DCOMs, certified those as factory certified OEM parts, as well as the compilation of new. We've talked about how we use those. So let's kind of go into that after part now, which is how do you now take those parts that have been removed from platform X and turn those around in a time, what's that time frame, how did that go, and then how's the QA follow all that? So we get to that point that Norm talked about where the government provides the RMC, the certified Connex box equipment ready to roll. So if you there's a jump ball for you guys, whoever wants to lead off on that process. But maybe Keith, we'll talk nuts and bolts, maybe the where it's done, the how it's done, procedure, and then Norm, and how we're going to get to the certification. If that's fair.
Sure. Well, neither one of us are real tall, and we're both old, so it's probably not like they're going to jump very high for that ball. But
maybe a scrum, not a jump.
Yeah. Again, it
I'll
gets
let
back
you get
to
it, buddy. I'll watch.
All right. Thank you, sir. I will say, it really gets back to teamwork and communication, right? Having a plan. If we didn't have a plan for the OQE that was going to be required to recertify those parts, we'd still be talking about, is it 1,000th or 3,000ths, right? So we really did put a lot of effort up front into what does recertified look like? What is the OQE that allows, us and the government to feel comfortable with that going on to an engine that's going to go into another complete life cycle, right? We're not talking about, just getting to the next availability. We're talking about going for another 36, another 72-month interval. So understanding what that was a key to getting that done. So now if you take the Connex box that went to the ship full of very good and capable and ready parts, and then we filled it back up with, Class F parts, and we send it back to our service center in Houston, where we're doing this work. And they receive the parts, they inspect them, they go through the whole rigor of the process and collect the OQE that they need, understand what needs to be replaced, what can be reconditioned. Certain things, that are wear components, that have wear components, you can only recertify so many times. I'll use a cylinder head as an example, right? There's so many turns of that crank. You don't really know what you're getting until you get it. So, our team has to be prepared for any outcome when they open that box, and they are, and that's really through having that process in place. And again, predicting failure rates for castings, predicting failure rates for cores, and being ready to respond to that. So when they come in, everything's taken down, everything's cleaned, it's inspected, it's measured what needs to be measured. As it goes back into reassembly, all of the components are charted the way they need to be charted per the OQE. And then all of that is placed in a single location so that when we're ready to ship that box, we're ready to ship that OQE. They can look at that, certify it. All of those components are ready for issue. There's no other work that needs to be done once they're down in the vessel other than, the assembly process and then the run-in. So it really was, again, kind of trying to stay ahead of the tide and making sure that we had everything in place that we need to have in place ahead of time so that we could be successful that way.
So in that
I
discussion,
really buy into reliability, where when we take the material in the previous process, your ship is in the yard. We've had open and inspect maintenance philosophy. We would go down, we would tear it apart. We would submit, the CFRs, and then we would go through this process of trying to find material and figure out where the material is at. And a lot of times, the condition of the components, it's stored in a CFR somewhere that never really makes it anywhere. And then it goes into an MD and it goes away. And it never really makes it back to the life cycle side to understand how are we operating our equipment. So one of the benefits that it really gives us, and this was a huge lessons learned for us in probably two main areas. One is machinery history, and the other is in supply support. So on the machinery history side, when the parts come in, we're in a much quieter time frame. It's in a downtime. The equipment is being rebuilt in a shop environment to where it's not all 100% production. They're documenting the actual condition. And as we all know, there's consumable parts that get replaced. Those non-consumables, the iron, the pistons, the rods, the cylinder heads, those items, we have the ability to now get inspection reports and understand, the service life. How many times has a fire deck been cut? How many intake exhaust valve seats are we up to? And how much service life is left in that equipment? The other benefit that we're getting out of this is we were doing engine overhauls on the SSDG in the 8 to 10,000 hour time frame. And a lot of times that doesn't line up with 36-month OFRP. And then you have your top end and bottom end on the PC 2.5, where at 10,000 hours, you would be doing your top end. What we found from reviewing the OQE and reviewing the data is that we could take our cylinder heads out to 14,000 hours. We can get the SSDGs, we can get those up to 12,000 hours. We can realign those into an OFRP cycle. So now it gets us into the point we can do them quicker and faster, but we can also get a better service life out of them. And we're catching them before they fail. And we're seeing in the SSDGs, and I know some of this is just a couple of years old, but we are seeing that some of the CASREP numbers drop, and so it's working on that end. On the supply side, when material is procured commercially, it does not get reflected back into the supply system. One of the things that we built into this process is at the end of each Connex box reconditioning event, all of the material that's used, the mandatory replacement consumables, the low frequency material, the hard iron, that is captured. And we're currently working with DLA right now to submit DHAs, the demand history authorizations, so that we're documenting the usage of the commercial material in the stock system so that our suppliers, using getting the monthly consumption rate right sized to the material. So we're getting what the sailor is using, we're getting what the commercial event is using, and we're starting to reflect actual material usage and right sizing that material. And with the machinery history event coming back to us and getting put into SAM, the machinery history module, and having that information, it's given the life cycle engineers here in Philadelphia the opportunity to really right size the maintenance to a failure mode. And we're really looking forward to the next round of coronametrics on the engines that we've performed the pit stop on, so that we can compare that to the regular O&I process. And really, we're going to a directed maintenance philosophy for the equipment, and really getting away from open and inspect, because in this current environment, in this time frame, and where we're headed in our political futures, everybody keeps talking about, we have to have readiness, we have to have our vessels, we have our North Star requirements, and that's where we need to be. Keith?
Awesome. So in that, just if I can, Keith, to put stop a couple of things there, that the supply support, that clear demand signal, colossal in great applicability to other arenas, absolutely. And so, and then when we talk in general terms about open and inspect versus this approach, and I think Norm and your team have kind of coined this, which is non-deviational directed maintenance strategy.
Yep.
Prescribed maintenance, clear understanding of output. You've hit some of the high points in regards to now it can go both ways, right? It can extend a mean time between failure or a replacement strategy, as well as it gives better insights. And then with the corona data, you get that backup of, now no kidding, how is all this working? I mean, there's lots of checks and balances built into this. And just for our audience, if you would like to start entering a couple questions into chat, please do that. That will give us a chance to kind of make sure that we're coordinating those. And until we start to see some of those, we'll go ahead. We've hit quality assurance. And we've kind of given a background here of what the benefits are, what we've learned to date. How do you look at pit stop as a model or a template? And how would you apply the principles to other complex system maintenance? Thoughts?
So right now, I'm applying the concept to the PA6B. We're looking at
For clarity for our
basically,
audience, PA6B is on what platforms?
it is on the LHA 8 and the LHD 6. So I think I got that backwards, but anyway, it's also on carrier platforms, and we're really looking, that's the next system. We are also looking at applying this to steam systems. We're looking at, I'm working with the steam group on the enforced draft blowers and other steam systems and auxiliary type components for them. And it's been discussed at CNRMC and other looking at other systems as such as air compressors, and those ISEAs are looking at that. We basically did our availability process is firm fixed price at this time, and we did a availability analysis over the LSD, LPD, LHA, LHD platforms, and we evaluated where our high cost drivers were and where our high variance was, looking at from planned, how we planned the availability and what was our actual cost. So then we took those systems and we started breaking them down into what was the cost driver and what was the issue. And we're currently evaluating each one of those vessels and those platforms for the prime mover and the troubled systems that support the prime mover. So HPACs, LPACs, cooling systems and the like. MRG team is currently reviewing their failure metrics and looking to see if there's areas where this can apply into that. So it's kind of the buzzword right now. It's the process. And we've built a new availability analysis tool that we're debriefing here with the Carter Hall availability and the Macon Island availability that helps us really identify where those cost issues are and those cost variance issues are. And we'll be putting that out within those reports out within the next week. So it helps us prioritize and target by realistically, where are we spending the most money in the most systems and what systems really need the most help and support. And it comes down to the maintenance philosophy. And if we look at how we've done maintenance and where we've done maintenance, we really have to look at it from a life cycle maintenance perspective. If things are condition based and we only fix them when they break, we'll always be in a reactive posture. And we have to look at the philosophy. We have to flip the script and say, what do we have to do? You know, the ship has a service life, we have a midlife, we have ship quarters in which we have OFRP cycles, and our service equipment has a philosophy as well that has to be addressed. So using this process, we can down select those systems and subsystems. And some components may make sense just to do a direct replacement, run to failure, replace, provision it as such. Others will be repair, recondition, and others like a prime mover, will be reconditioned in place. Keith?
Awesome.
Yeah, and just in kind of going back, but on the same topic, right? So a couple of things, concepts were mentioned, right? This non-deviational directed maintenance and predictable outcomes, right? So if you think about, it doesn't really matter what the piece of equipment is. You can go into that piece of equipment during availability A or availability B and say, hey, here's a CFR, I think we should do X. And in availability A, they say, yeah, it's a great idea, let's do that. In availability B, they say, oh, we don't have time, can't afford it, I think it's fine. You're still marching to the next availability, but now you don't have a predictable outcome. You don't know in both situations how far you're going to get. If all of the work that went into the evaluation of the components that are mandatory and non-deviational that we are going to replace, give you that confidence and give you that ability to know that your odds of making it to the next availability without a CAS rep, without a failure, are significantly improved. And you don't have the ability to go back after each one of those and say, oh, we should have done this or we should have done that. This takes all of that guesswork out of that. And I think that's extremely powerful for the fleet to understand that we now have something that we can really feel confident is going to make it through this deployment, is going to make it to the next maintenance availability. We did everything that needed to be done and in the right way, and it's certified by the folks who know. And I think that's a big win in this that is kind of can be really overlooked very easily.
Yeah, there's a true baseline reliability and readiness in certain colossal. I'm gonna shift to a little more group chat here if we can with as we got some questions coming in, and I'll take the first one. And the question is there a flag officer or SES championing this idea? Absolutely. And so when you look at, I'll say that Norm hit really well the current reality, the problem state of the LSD were on the chopping block forever. Prime catalyst number one, amphib readiness, and that was prompted by readiness review, prompted by statutory requirements that 31 amphibs is a floor, not a ceiling. So how do we best utilize those assets that we have today, and how do we bring them back smartly to operational service? So between SWOBOS, fleet Fleet Forces, Admiral Wolfson, oh my gosh, a rock star, real advocate, and her entire team. C-21, Bill Green, early champion and proponent of this, as was CO5, with both the CO5 front office as well as Marine Engineering, the Tech Ward holder. Philadelphia, oh my gosh, just leading the path on this. SES, when you look at other SESs, CNRMC and Eric Lynn, Eric's been down on the deck plates during all those first couple executions, firsthand witness, and be able to validate that this is something that makes sense. And so a great understanding, I'll say a common lens to understand a problem, and understanding that there's enough work to go around. How do you buy the expertise of the OEM, the expertise of the supply system, the expertise of the ISEAs and technical community, and blend those on a common focus to be able to solve those with the right leadership support and the burning platform to get those done. So really appreciate that question, and really the importance of having clear advocacy and support through the leadership ranks. In regards, there's a question on, seems like a reasonable approach, who funds the effort? Any just kind of general comments on the approach to programming, planning and funding? Norm, will put that in your lap.
Yes, it's actually funded out of the ship's maintenance budget, and we see very through our pilot, we saw very little difference between what we budgeted already for our diesel maintenance in the CNO process and the pit stop process. And things were pretty much aligned, and it aligns with the MRID and the funding that's provided through the ship sheets. So directly from the maintenance team and the type commanders.
Awesome. There's a question on a slide presentation. I'm just putting in the chat a link to our website that has the press release on pit stop, and as give some examples and a little additional detail there. So let's see if we got any other questions coming in. Talked about the funding, and we've talked about champion, the importance of that. Keith, Norm, as we're coming here to about 9 minutes left, any final remarks, points that you would like to highlight in this forum? And we greatly appreciate those. And I'll start with Norm, and then we'll go to you, Keith, and then we'll see if we can't wrap this up. Norm?
Yeah, the quality control, the process, work, how we work, with everything put into the technical work documents, and having everything identified right up front, and having everybody on the team. And this is, from the RMC QA side, the RMC production, code 300, code 200, the diesel inspectors, and code 264, having everybody aligned and having that diesel council is the success story of this process. And clearly, we use it in the submarine platforms, in our submarine refits, and we use it here. We're also using it in other platforms are starting to use it in their regular diesel maintenance, and availabilities go into a weekly diesel council in the CNO avail. It has the right people on the deck that make the decision on the deck, and the PM has to be a part of that process, and the prime and subcontractors to make it work. And it takes effort from every individual in that process to make it work. They have to go away from that meeting and go push the barriers out of the way. The biggest barrier in the process is the actual condition of the equipment when you get in the space, because as I alluded to, there is support systems that are required for that prime mover to operate. And you can be done and have your prime mover ready to go, and those support systems not ready to support you. We have assembled a POAM for the vessel. We've gone through all of their parameters, all of their guidebooks, and we've put together a philosophy for them to ensure that their space is ready to go, and that way we're ready. And we've had some successes on the ship restoration side, and we've had some less than successes on the ship restoration side that have caused the extensions. The prime mover was ready to hit the start button and go, but the onboard systems weren't quite there. So that's probably the highlights is the QA, the diesel council, the POAM for the ship's force, and walking in with it's just basically an integrated production schedule right up front where everybody knows what has to happen and where they need to be on what day are the key successes to our process here. Keith?
Outstanding. Thanks, Keith.
Thanks, Norm. Yeah, I concur with all of that. I would say, the only thing I can really tack on to it is, having everybody stacking hands on, we're not going to get where we need to be by doing more of the same, right? And so we, again, that level of teamwork, that level of belief that, there was enough expertise in the government and enough expertise in industry to come up with a very, very viable solution. And, again, proving that, when we work together, we can accomplish great things. And that was really, I think great for all of us. It's really easy, when you don't know what the outcome is supposed to be, to get mired down in a lot of extracurricular stuff. And here we know what the outcome's supposed to be. We know who's bringing what to the table and when, and it makes it very, very easy for everybody to make the right decisions along the way. So again, teamwork definitely is a huge part of this. Recognizing the talents of all of the organizations that come into this and the value that they bring has been really helpful in allowing us to get here. And I can't thank Norm and his team enough, in Philadelphia for all of the hard work that they put in supporting this and allowing us to bring our capabilities to the table. And I can't thank enough the people who are overseeing and looking in and giving us the rope that we needed to get to where we needed to be. So it's been a great process for all of us, and I think it's made the team a heck of a lot stronger, and it's given us something that we know that now when we see the ship sailing away, we feel very confident that it's going to meet its mission.
Confident.
And I guess the last one thing that we failed to mention too is it moves or it removes the diesel prime mover from the critical path within the availability. And having that contingency material and set up to support that growth work. Now we can work on bilges. We can work on auxiliary seawater piping. We can work on those other systems that you cannot get into when you have a diesel open for 3/4 of your availability. So there's really there's multiple unseen benefits of this process that really come into the factor when you're looking at the production schedule and how do you integrate all of the work within the space. This really takes that out of that equation entirely. We can lay the engine up, we can wrap it in plastic, we can do the work in the other engine, in the other space, and get on with it, come out of the availability and be ready to move.
Awesome. And well said, Norm. And that was going to be kind of one of my get off the stage points. This is an overall net benefit to total ship ready. This is a direct correlation to how we improve readiness of 31 amphibs. And I would be remiss if I didn't highlight we're talking about champions across Navy and our forces, the advocacy from the Marine Corps, particularly Sean Brody and his team, huge, because this is the vital platform that brings that expeditionary capability to the country. And so we'd be remiss if I would mention the support and alignment from our Marine Corps brothers and sisters. The other, I'd say, big mover in this, it's one of those nuances, but all too often we get stuck in our community silos. A lot of our components don't care if it's a surface ship, if it's a submarine, or if it's a carrier, right? And how do we start to blend those? And so the good idea of the Diesel Council, as we talked, began, its origin state was on submarine availabilities, as were the seed corn for this process. And so being able to learn and how do we then exploit at scale for mutual benefit are kind of those key things. And so Dale, as we come up to our time here, deepest appreciation to those that took the time to sit in and listen today, for your questions. We are always available. You can feel free to reach out to me or Norm or Keith with any follow-on questions. So thank you for the time you took to participate. Norm and Keith, you guys are rock stars. Thank you for what you're doing. Get your nose down, butt up, get back to work. And then finally, for ASNE, oh my gosh, Dale, thank you to you and your team for your 137 years of dedication to advancing the cause of naval engineering and excellence, and for sponsoring today's event. So thank you very much.
Well, I just want to thank you and your team, because you still have another webinar. Because they're corporate partners of ASNE, they get several free webinars. Other people on the call, if you want to host a webinar like this, it's very professional development, informative for all the attendees. Please contact us. But Jim, your team there just reminded me of being on pit stop right on the row. I just didn't have the loud sound, but otherwise it was great. We have recorded this, so it's going to be available on our website, and we'll provide links for other people to view it in the future. So thank you. This has been great.
Thank you all.
Thanks, everybody.
Have a
Thanks,
great
Norm
day.
and Jim. Thank you.
Thank you all.
Take
Out
care.
here.